Welcome to Study Loop.
So in this question, we have a sheet of plate glass of thickness T, and we inside a ray of light in it, and we want to know, we want to prove that the light ray comes parallel to the initial beam, and that for small deviations, we can write the displacement between the where the initial light ray is and the final light ray in terms of the angle and the index of refraction. So first we can write the law of refraction at point A. Let's call this point A and point B. So the law of refraction here gives sine of theta is equal to n sine of theta 2, theta 2 being the refracted angle inside. So theta 2 is here, theta 2. And if the angle of emergence here is theta 3, we can write also the law of refraction at B. So n sine of theta 2 is equal to sine of theta 3. And theta 3 is the angle of emergence that is this angle here. And now we can combine the both expressions. So we get that sine of theta 3 is equal to sine of theta, as is drawn in the picture. So this will be theta 3. And this means that the rays are parallel to the incident ray. So this ray is parallel to this ray because this angle is equal to this angle. Now we wish to derive expression for x in terms of theta. We can draw this small triangle here where the basis here is the distance x, and use trigonometry here to find out what is this distance x for small angles. So we can call the distance of the light ray inside the glass, so this line here, d, and if this distance is d, and we know that this distance here is t, and we know the angles inside, we can start finding something. So we can find first that d cosine of theta 2 is equal to t. This means that we can write t in terms of t and cosine of theta 2, and we know these things. And the internal angle here is theta minus theta 2. So we get that x is equal to d sine, let's call the internal angle alpha. This is d sine of theta minus theta 2. So we can write this as t sine of theta minus theta 2 divided by cosine of theta 2. So for small angles, we can approximate this by theta minus theta 2. And the law of refraction also applies, and we approximate them. So let's do the approximation. So the approximation is that sine of theta is approximately theta. Cosine of theta is approximately 1. So we get that x is approximately t theta minus theta 2. But we can use the approximation in the law of refraction here that says that theta is approximately n theta 2. So we can write theta 2 as approximately theta over n. So x, using this here, is t theta minus theta over n. And we can simplify this as n minus 1 over n d theta. So this is the relation of the displacement of the beam with the initial angle. If the angle is small, the angle theta being small here, and look at this.